Now that we have constants and predicates, we can put them together to make atomic sentences, which are the most basic type of sentence, which can be true or false. So in the first lecture, we saw constants like A, B, C, and so forth. And in the second lecture, we saw predicates like tall, left of, and between. And we spoke in the second lecture of the arity of these. Tall has arity 1, it takes one argument. Left of has arity 2, and between has arity 3. To make an atomic sentence, all we have to do is combine these with the appropriate number of arguments, that is to say, a number of arguments that corresponds to their arity, to get statements like A is tall, B is left of C, and so forth. These are our atomic sentences, which have the characteristic properties of being capable of being true or false, and also are the most basic kinds of statements which can be true or false. That is to say, they can't be resolved into anything more basic than they are that's also true or false. Predicates like tall or left of, said on their own, don't say something true or false, and neither do names like Andy or Max or B. So that's why we call them atomic. Now there's a very special predicate which we're going to deal with a lot, and that's the predicate equals. We could write this as follows: A equals B, or we could even write it using the familiar equals sign, but putting it out in front like this, the way we do with the word equals. This is called prefix notation, because the predicate comes before. This is what we'll be using for all our predicates, except our special friend equals here, which we write in INFIX notation, in the familiar way of A equals B. And that's it. I want to wrap this up by turning to Tarski's world and just giving an example of making sentences true. So here are three atomic sentences. A equals B, A is a cube, and B is to the right of C. So we'll click here in the upper left-hand corner and introduce an object. I'm going to, there we are, we can view it from above. And here we have a cube. I'll make it larger so it's more easily visible. So if we name this cube A, then we'll make the sentence correct. We can check this by clicking the TF up here in the corner. Now we can make the first of these sentences, A equals B, true by applying the constant B to this same cube. Recall from the first lecture that one object can have many names, but one name cannot name many discrete objects. Okay, so our cube is called AB, and that will make the first sentence correct. Now we need a second object for B to be the right of to make the third sentence true. So we'll drop in another object. And just for variety, let's make this a dodecahedron. Okay, now B is to the right of this. All we have to do is name it with the constant term C, and there you have it. All of our sentences are true. Here's one further thing. We can rotate the board, and then certain of the spatial relations change. In which case, A is a cube still comes out true, and A equals B still comes out true, but B is to the right of C comes out false. And that's just a brief introduction to Tarski's world.